Alright, so here's a video for lesson number 12. Excuse the dog barking in the background. It's my neighbor's super annoying dog. So for this lesson, we talked about graphing factored polynomials. Some in the lesson were factored, some of them were not factored, and we had to do the factoring ourselves. So let's take a look at number 1. Number 1 is already a factored polynomial. So from this factored polynomial, I know that the three solutions, or three zeros, are going to be -3, -1, and +2. So the first thing I'm going to do is I'm going to graph those 3 points, -3, -1, and +2, right on my x-axis. Now, because it didn't give us any other information, I could go through and graph this polynomial. Now, one of the things that I would expect some of you to be able to do is notice that, one, this is cubic, because it would be x times x times x, so this would be a cubic graph. So I know it's going to look something like this. We'll talk more about that in a future lesson. But really the thing that we should have gotten from the lesson was, if I multiply these last 3 digits, that gives me -6. So that's actually going to wind up being my y-intercept. So if I go down to -6, I could also put a point here. I also could have gotten that by just plugging in 0 for x. That's the easier way to do it. So if I go through and graph this in my calculator, I might even get some more points on my calculator, but it does just say to sketch. So I'm going to have something that looks like this. Make sure you label f of x. And the key points, the x-intercepts and the y-intercepts. Well, let's look at number 2. Number 2 says to algebraically determine the zeros. So to do that, we're going to set 0 for f of x. So I have x cubed minus 2x squared minus x plus 2. I could do some factoring. The grouping method works best here. And I see there's a GCF of x minus 2. And I can keep factoring. And there is my factored polynomial. Each one of those are equal to 0. So now I have zeros of -1, +1, and +2. Also have a y-intercept, if I plug in 0 for all the x values, of +2. If I just graph it, I'll see that also on my graphing calculator's table of values. And if you're really good, you noticed right here that told you this value, because everything else had an x attached to it. Alright, so let's take a look at my graph. So I'm just going to kind of estimate where the points are. -1, +1, +2. Again, this is a cubic graph, so I kind of know what it looks like. I also know that the y-intercept is at 2. So my graph's going to come up, back down, and back up, and look something like this. Notice for each x-intercept, I'm passing straight through the x-axis because each one had a multiplicity of 1. Alright, so one of the things we have to realize is odd multiplicities pass through the x-axis. Even multiplicities are going to wind up being tangent to the x-axis. Going along with what we just talked about, the multiplicities, let's look at number 3. So number 3 gives us 3 different solutions, each with its own multiplicity. So let's just state the zeros. So x equals -1 with a multiplicity of 7, 0 with a multiplicity of 4, and +1 with a multiplicity of 2. Then we could describe what f of x really looks like just by knowing the multiplicities. I don't even have to actually graph this in my calculator. So I know f will pass through the x-axis at the 0, -1. And I know f will be tangent. Remember, tangent just means touches and comes back down to the x-axis at zeros of 0, and 2. Because at, 0 and 1. Because at 0 and 1, the multiplicity is even. At -1, the multiplicity is odd, so that tells you what the function's actually doing. Now, if you were to go through and graph this in your calculator, you could even see that right on our table of values and by looking at the graph. Let's look at 4. 4 says create an equation for the cubic polynomial that has a y and x-intercept of 4, -3, and +2, and has a y-intercept of -18. So the first thing I have to do is I have to create an equation. So I'm going to say y equals k times x minus 4, x plus 3, and x minus 2. I'm using k for a constant value because I don't really know what the multiplier is going to be. So if we go through and plug in 0, right, because this is the point 0, -18. So if I plug in the y value of -18 and 0 for x, I can solve for k. So if I do some quick multiplication, I have -18 equals k times, what's that going to wind up being? -12, +24. Divide both sides by 24, and I get a k value of -3/4. So now that I know the k value, I'm going to plug it back in to this factored form here to write my final function. And since it's a function, I'll give it a function name like f of x or p of x, something like that. So we'll call this p of x equals -3/4 x minus 4, x plus 3, x minus 2. I can even check that by plugging it into my graphing calculator, and I'll see that 0, -18 is a point on the graph, just to kind of check. Number 5. Number 5 says, sketch a graph of p of x, where p of x is x plus a, x minus b, x minus c, where b is larger than c, and assume that a, b, and c are all positive. Alright, so if we're going to sketch, let me first start by making an x and a y axis. So here's my x and y axis. Label that up. And then let's talk about where these x-intercepts are going to be. Where are these zeros going to be? Well, if a is positive here, that means a is a solution, negative a is a solution. If b is positive, that means b is a solution. And if c is there, that's positive. So because of the factors, right, we always go opposite. So x plus a gives you a solution of negative a. X minus b is going to be positive b, and x minus c is going to be positive c. Now I want to put all these on my x-axis. The easiest one to graph is negative a because it's only negative point. Then it says that b is larger than c. Well, if b is larger than c, that means b is way over here, and c is somewhere closer to the y-axis. Okay, so that's a key piece there that I could see some of us possibly missing. Then I know that this is a cubic polynomial. I know it's cubic because there are 1, 2, 3 x values. All cubic polynomials are going to look something like this. So I know this graph is going to come through the x-axis at all 3 points because they all have a multiplicity of 1. So my graph should look something like that. Again, it's a sketch. There's no real numbers, so we don't really even know what the y-intercept is going to be. All right, we can assume, especially for those of you in accelerated, the y-intercept would be equal to whatever a times negative b times negative c is. So the y-intercept is going to be equal to a, b, c. So I could even get crazy and put that up there. That is whatever a, b, c is. One of the things we have to be able to do for these kind of questions is go through and actually do this with variables instead of numbers. It really shows a true test that you actually know what you're doing. Also, this is an easy way for the people that make the Regents exam to give you a question where you actually can't use your calculator. which I know some of you really do not like. Hopefully this video helps. If you want to follow my channel, that might give you some updates. I don't really know what this looks like on your side, so hopefully these are helping. Have a great night.